And there are scientists that, like the crazy scientists you can imagine from movies with
That
like
would be
big,
me. Yeah.
yeah, and those
The
exactly,
hair all like this. Yeah. That's how I am when I cook.
yeah, and those will be more intuition. And I think progress in science really requires the combination of the two.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
On today's episode, data management in manufacturing from ideation to full-scale production with Ori Yudilevich, CTO of Materials Zone.
Uri, welcome to the show.
Thank you, Darren. Really happy to be here.
We had a nice conversation. When was it? Earlier this week or last week?
Yeah, last week, I think.
Last week, yeah. And I was a little skeptical on what you guys did, but you convinced me this is something really interesting. But before we dive into the problem space and things, Uri, tell my audience a little bit about yourself and your background.
Sure. Yeah, so my name is Ori. I live in the Netherlands, originally from Israel. Also spent a lot of my childhood in the United States. I'm currently CTO of Materials Zone. We'll discuss that today. I kind of have a very mixed background in both in software, which I've been doing from when I was a kid. Worked in a couple of companies along the way, and also spent many years in academia. I started off studying physics and chemistry, went into theoretical physics, and eventually did a PhD in mathematics, and also a few years of research as a postdoc. And then coming back into industry, somehow ended up in this wonderful company I work for now, Materials Zone. I've been there 4 years now.
All right. So the big question I have for you, since you've been coding since you were a kid, what was your first computer?
My first computer was a Commodore 64. not mine.
All right. All right. Well, we can talk now. We can talk. Because I'm always afraid to ask people now because, yeah, my first computer was, a laptop. I'm like, all right, Commodore 64. All right. Yeah, that's pretty cool. That's awesome. So, Uri, what switched you from academia to where you are now? What was the thing that said, "Hey, I'm going to be the CTO of a data company"? Because basically, that's what you guys are.
Yeah. Well, so when I switched from academia back to industry, I didn't really know that I'll be a CTO of this company. But I think it was a combination of two things. So, somehow high-tech software product development was always something that intrigued me. I worked before my studies in a company, so I always knew that I want to get back to that. I even had like an attempt at a startup for a few years when I was studying. So it was kind of natural for me to go there. But when I was after my PhD, I did have a few years of a dilemma. Do I stay here and have like the comfortable life of a researcher or a professor? Academic life is quite tough. So high competition. You have to move around a lot. So it was really a combination of life circumstances and passion to go back to software and build a really cool product.
No, that's awesome. I'm a software engineer by trade. I've been in executive management and I've been all over the place too, but I always go back to software. That's what I do for fun is write code. It drives some people crazy, like my wife. She thinks it's hilarious. So,
yeah.
All right. So let's dive into the problem space. I didn't know it was a problem space, but it absolutely, once you described it, it absolutely is. So what problem do you guys see that's out there today that most people don't know about?
Yeah, so the problem space we're in is development of products that are material based, right? And products that are material based is basically more or less any product, right? Any physical thing that you have around you is materials based, right? Materials can be wood, can be plastic, can be metal, can be glass, and all these, the most simple thing around you. There's a lot of research into it, right? Sometimes you can even trace it back to hundreds of years back, right? Like just like anything in science, and this process of building new products for materials it's very challenging. In a lot of ways, it's a bit like cooking, right? Like you have ingredients, those are the materials, you have to mix them. There's a process, right? Cooking, it's like the cooking time, the temperature. So in products, it's much more complex. There could be hundreds of steps. There could be hundreds of ingredients, right? So you have this huge parameter space of possibilities that you have to try out. And the original way of doing it, the classical way, is trial and error. And trial and error is a very expensive way, and progress is made much slower when you go that way. And today, there's a whole new realm called materials informatics, where more and more data techniques, whether it be just data management, just having things digitalized, whether it be like applying statistical methods, and of course machine learning and AI. All these things can really save the number of trials you have to do until you reach the thing you're looking for, and sometimes you can even go beyond what you thought you can reach using. So it's really about accelerating accelerating product development. That's kind of like, if you want 3 words.
When you mentioned cooking, the first thing that popped into my mind and was the way that I cook. My wife and I both cook. She cooks very differently than I do. She follows a recipe. And if it's one of her recipes and she wants me to cook, I have to follow her recipe exactly. Right? The way I cook is I can't repeat the same recipe twice because I just cook off the cuff, right? I just like, all right, I think this will taste good and I think this will taste good. Do you think that research has been happening that way? It's kind of more ad hoc in the past, where they're not using real process scientific method to say, hey, we want to make sure that this is repeatable, where we can build or make something better. Is that how it's been?
Yeah. So first of all, the analogy is perfect. I'm going to use it from now on. So I'm much more like your wife. I'm much more like your wife. You're kind of more like the artist type of cook, and
I'm the artist, yeah.
and definitely product development has the combination of the two, and also people that do it. There's different types of people, right? There are scientists that are much more systematic, like your wife and me. And there are scientists that, like the crazy scientists you can imagine from movies with like
that would be me. Yeah.
Yeah, and those exactly.
The hair all like this. Yeah, that's how I am when I cook.
Yeah, and those will be more intuition. And I think progress in science really requires the combination of the two, right? Like maybe breakthroughs, for real breakthroughs, you often the scientific method of being very systematic won't get you there as fast, right? You really have to try something completely new, right? Like these conductors we've been hearing of that have been discovered, where they go into, it might be completely wrong, but they went into an area that nobody even thought of looking at, right? And you probably won't reach that if you really follow, what really, tweaking and changing. So it's really a combination of the two, like a beautiful analogy.
Well, so what's important though in this whole thing, even especially when you have intuition-driven developers, right, or researchers, right? They're just going off the cuff. You need to capture what they've done, otherwise it's not repeatable, right? And that's a problem that we have. Would you agree? Yeah,
definitely. So that we call it like knowledge loss or knowledge preservation. So that's a really big problem, right? And it's not only about people leaving, right? So when you think of knowledge loss, you think of maybe people, going to pension and then leaving the company, and that knowledge is lost. but it's sometimes even the same scientist, right? The same R&D engineer performing some experiments, and then the next year they have to do something similar, and since they
And they
haven't
can't do
stored
it.
yeah, since they haven't stored in one place, they have to start all over again. And today we're much more collaborative, much more international. We had one client that where the process, and this is pretty common, the process of creating the product was really cross country, cross continent, right? So some of the process was done in Central America, then the product moved to the US. Another part was done in one state in the US, moved to another state of the US. So you really have to work in an organized way. Just keeping notes on a piece of paper or even on an Excel file is not enough to keep the knowledge around. And that's not even going into the question of machine learning and how you can
You,
leverage that.
we used to call the term loss of knowledge. Trucking factor. That was the term we use. It's horrible. It's a horrible term. Um, because we, on my team, it was in 1999, and the last millennium. For all you young listeners, that's pre cell phone or pre smartphones, right? But last millennium, in 1999, I was working for a company, and we had we were in charge of DevSecOps for this big, huge project. It took like 20 days to produce the product. Every time there was a release, 20 days. And we had this one guy that he had a critical section of it. He didn't write it down. No one else knew how to do it. And he was riding his bike and he got hit by a truck and died.
Oh,
Very
man.
sad story. It took us 4 months to figure out what he had been doing. 4 months. So from that point on, we called it trucking factor. We said you can't have a trucking factor of 1. It has to be at least 2. 1.5 is even better than 1, which means I wrote it down. But everyone had a backup. Everyone knew how someone else did something, so that we never ran into that problem again, because it completely tanked this massive product that we were shipping because we didn't know how this one section of this process worked. So this is very important. Knowledge capture, knowledge. A loss is a big real issue, not just in material science either.
Sure. And you also have to add, first of all, that's a tragic story, and
Yeah, it's horrible, but we still use the word trucking factor.
yeah, so there's the issue of loss. There's the issue of findability, right? Like being able to find the data, right? Could be that you're documenting it, but is it can you find it? Did you index it in a proper way? Which could mean like putting the right keywords. Do you have many systems? Like how many systems do you have to search through to find your data? So that's another aspect of this.
So, real quick, let's talk a little bit more about the approach that you guys took to solve this knowledge capture problem. Because with materials science, it's not as easy to capture, I would guess, because you've got people that are working in the physical world. In the software side, everyone's on a computer, right? I can more than likely capture what they're doing, right? Even if I'm just capturing keystrokes, and work that out later. But when you're doing material and product development in the physical world, that's a different story, right? So how do you overcome that physical to digital gap that you have?
Right. No, so that's actually a big challenge that we face, because people work in the lab. They often don't look at the computer for the whole day. Sometimes
I can't imagine a job like that. It doesn't register for me.
Sometimes you can't even have a computer in the lab where you are because it's maybe a bit, there's too many liquids and things that could destroy the computer, or you need to put it behind some kind of protective layer. So this is a problem, and I can't say we completely cracked it. We've had users that installed tablets in their lab, put the tablets behind like a plastic protective layer, and then entering the data as they do it, right? But sometimes it's really writing things on a piece of paper, and then when you finish the day, you go to the computer for 20 minutes and you have to insert all the data. The best thing where we try to make this easier is automation, right? So really connecting to measurement devices, right? So, some things you just have to read off a screen, but sometimes you can, in material research, or we even work with domains like batteries, right? And in batteries, you do something called cyclometry, where you just like charge and discharge a battery over and over again. And then you have these big machines, they collect a lot of data, and this kind of data you can just have flowing into a platform like ours. So it's really a combination. So it really depends on the type of research which is being done. Sometimes it's easier, sometimes it's harder, sometimes it really requires a lot of change management.
So what I find interesting is you've got data that's digital and analog, or digital and the physical data. You guys have come up with a way of collecting all the data, right? At least a more central repository for all that data. And I imagine that data is not coming in rows and columns for a database most of the time, right? It's scientists' notes. It's a whole bunch of different things, right? Is that kind of the space that we're in?
Yeah, definitely.
Structured and unstructured data all over the place?
Yeah, definitely. It's so first of all, the data is often not tabular. It doesn't really fit in a table. I kind of think of it more as a graph, right? In terms of like nodes and edges, because there's different instances of where you can see a graph, right? For example, if you go to this example of this battery, the battery development that I discussed, then what you have a battery. A battery is made out of a cathode, electrolyte, and an anode. And then each one of these is also made out of raw materials, right? And those can also be made out of raw materials. So you really get this kind of tree-like structure that describes your data, right? So this is not a tabular thing. This is in general true, right? Whenever you have a product, it's made out of ingredients, but those ingredients are always made out of ingredients and made out of ingredients.
So right, it's like an aggregation. There's a lot of relationships going on there, right?
A lot of relationships, yeah. And then also the process itself. So sometimes we also look at manufacturing. We can discuss that in a second, but like the process of an R&D is not only about the R&D, right? It's really about the R&D feeds from all the other parts of the process, and that could be procurement, regulation, sustainability, and also manufacturing, right? There's kind of feedback loops in all directions, where anything that gets measured, anything that has properties can affect the development of the product. And in the manufacturing line, for example, again, we have a client where we saw this. You have things like you have a certain batch of some of the raw materials, and then that batch gets split up and it gets merged with another batch. And you really get this kind of very complex route that the product goes through, and you have to capture all of that. You have to find a way, and I think that's what makes also our product special. The data structure that we have, it's really kind of tailor-made to this kind of research, to product development research, which is different than.
So I like what you described there. I'm moving from research on material science or product development into mass production. That's a huge problem for a lot of companies. They spend years trying to. I made this in the lab, but I can only make it in small quantities. How do I now make it in mass quantities so I can sell this product more at a lower cost and lower price? Right. That's where you guys kind of fit in. You bridge that gap between data capture in the research side into manufacturing best practices and process.
Yeah. So when we talk about R&D, we don't only talk about developing like one prototype, right? We think of R&D as actually 3 steps, right? There's R&D itself, there's scale up, and there's production, and each one of these parts of product development is very unique, right? There are overlaps, but the challenges are very different, right? So when you're in the lab and you just want to find that like one, best, I don't know, let's say you're building a solar panel, right? So you want to find one which works well, which is the most efficient, right? So you're really obsessed by increasing the efficiency. But then you say, okay, now I need to manufacture, 1,000 of these an hour or a day or something like that. And then you start producing it and you run into new problems that you didn't even realize you have, right? So you get a whole new set of problems. There are similarities in the type of research that you do, and you're doing trials, but you're doing it at a different level. You do it in different with different methodologies and different challenges. And then when you go to manufacturing, it's about stabilizing, right? So in R&D, when you're in the lab, you're actually trying to increase variance. You want to try as many things as possible. Go crazy.
Yeah, exactly.
And when you're in manufacturing, it's really just about stabilizing. You want the same thing to happen over and over again, and that of course never
Decrease
happens.
variability, right?
Exactly.
Get rid of variability. You want it consistent, right?
Right.
So that's interesting because those are diametrically opposed to each other.
Yeah, they are, but the methods are not, right? The statistical methods that you use are not completely different, right? They are different, but we've kind of built a set of tools that some of them fit the one, some of them fit the other, and some of them fit both. But the most important thing is that the data is all concentrated in one place, because data from manufacturing of one product can later help manufacture R&D of another product. Right? So even though the statistical tools might be slightly different, you still want to have the data as unified as possible.
Let's dive into your solution set. We've talked a little bit around it. So you guys do data capture. I've got a central place. It sounds like it's more graph database based, which I love, right? Because I can do structured, unstructured data that way. So I've got capture. I've got some analytics. Is there process involved? Give me kind of a high level overview of what you guys have put together to make or to help companies move through this research, scale up, and production process.
Yeah, sure. So Materials Zone is it's basically an end-to-end materials informatics platform, and we like to say that it's a platform that enables lean R&D processes. And let me explain.
Oh, nice. Lean R&D. That's interesting. Yeah.
So let me explain these words and why I use the word end-to-end. I think material informatics we've covered, and why I used lean R&D. So end-to-end has to do with what I just described, that when you do research and development of products, you can't just be siloed and focused in your lab, right? Just in the data of your lab and the properties of your material, right? You really have to have a connection with all the departments of your company. So you need, we discussed already kind of the connection to manufacturing, but let's also touch on other things. So there are different challenges that are becoming more and more prominent today. For example, regulation. Regulation is something which is increasing a lot these days. Very geographic dependent, right? So if you're trying to sell something in Europe, you'll have EU regulation. In the US, you'll have US regulation, and so forth. And these regulations are becoming stricter. So just to give an example of what I mean, think that you're producing packaging, right? Like a plastic bag for pasta or something.
Okay.
And you have toxicity restrictions, right? You can't use any type of plastic. And these things are changing all the time, right? So something that we think is okay to use today, next year it's not.
Isn't okay next month or next year.
Exactly. Yeah. You need to adapt quickly. That's one aspect. Another aspect, and by the way, a lot of big companies, they have a regulation department, right? So the regulation department needs to talk to the R&D department. So that's why I'm using the word end-to-end. Same thing goes for sustainability. That's becoming more and more prominent today. Something called carbon footprint. It's kind of like a number that you have to attach to your product, and that number is computed out of other numbers of your raw materials, of the transportation used to bring those raw materials, all of these things are parameters, right? In the past, we would just look at, the strength of a material, and that's all you would care about when you would, build a
Right.
concrete.
Yeah. Yeah.
But now you have to start looking at, how much carbon is being produced when I build it. Supply chain is something that is, very problematic in the last couple of years, and material that is available today is not available tomorrow. All of these things. So that's where end to end comes from. And then this connects to what I said, what I called lean R&D. So lean R&D, I think a lot of people are familiar from manufacturing, Toyota, lean startup, lean software development. What this
Yep.
means is lean is thin, right? Reduce waste, and that's kind of what we aim for. We aim to reduce waste in the R&D process. Is the number of experiments you have to perform, the amount of materials you have to buy, carbon footprint, as we discussed. So our platform, it does this connection between all the data. We have this analytics and machine learning layers on top of that, and everything in order to accelerate and reduce waste of product development.
So have you captured a lot of best practices in this area and put those into your analytics so I can take advantage of industry best practices? Let's say I'm brand new into plastics. Let's say I'm doing plastic. You brought up plastic bags, right? So I'm brand new into plastics. And do you have like kind of best practices cooked into the analytics so I can say, all right, I go through this and here are some things you need to watch out for, type of thing. Is that kind of what we're getting out of this as well?
Yeah, in certain ways, yes. In other ways, no, or I would say not yet. It's a good direction. So for because of security and privacy issues, then we don't share data, of course, between companies, and we're very
Between
careful
customers. Okay.
with
Yeah.
customers. So we're very careful. Like lessons learned in one customer, we don't pass it to the other customer, and lessons learned are also how these guys are working very well, very efficiently. It's not something
Right. So it's a competitive advantage.
exactly. However, in terms of tools, in terms of statistical methods, in terms of machine learning methods, these are things that we develop. This we do. I mean, that's kind of the point of Material Zone, is to make data science, machine learning, AI, statistics available to people that are not familiar with these things. Right? This is not something. This is not what they spent their degrees doing. And we bring that to them at very low cost, right? So no code for those that cannot code. We do have some coding opportunities for people that do have some data scientist
Like you and I, right, Ori?
like us. So yeah, in terms of like analytic tools, statistical tools, then what you said is right. Like we do kind of out of the box make these available and give webinars and so forth.
So it's not just the tools, you're also doing some training and things like this. So
Definitely.
what this means is you've decreased the barriers to entry on leveraging data science into these manufacturing, because you don't want to develop a whole huge department for data management for data scientists and analytics to all create your own tools when you're focusing on material science or you're focusing on product development in the physical world. It's almost a loss. There's no immediate benefit. There's only benefit in the long term, which a lot of executives can't
Definitely.
afford. Right.
Yeah, I was surprised, by the way, how we've worked with a couple of Fortune 500 companies, and like kind of your instinct is like, oh, they probably have dozens of data scientists. What can we help them out with? But it's surprising how that's not the case, right? Because as you said, they're really focusing on logistics, on manufacturing, and actually even a small startup like us can has a lot of value that can bring.
That's awesome. So, Uri, if people want to find out more about Material Zone, where do they go? How do they contact you? What's the process?
Yeah, so we have a website, www.materials.zone. You can contact us by email, contact@materials.zone. You can find the email address on the website. And we have a sales team, a support team that is just waiting to receive your call.
Waiting to answer your call, right? This is a fascinating area, I think, and I always learn something new. So thank you, Uri, for coming on the show today.
Thank you, Darren. This was a lot of fun.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.